AB Calculus Note Card 36, Increasing and Decreasing Functions. This is the 36th video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this note card system. Increasing, decreasing functions. Let f be a function defined on an interval I, and let x sub 1 and x sub 2 be any 2 points in I. Then f increases on I if x sub 1 is less than x sub 2, and f of x sub 1 is less than f of x sub 2. And so to take a graph of what this looks like, it's going to be if you have a function like this, and if we have x sub 1 and x sub 2 as our input values, and for all x in this interval, if f of x sub 1 and we have up here f of x sub 2, and so you're basically looking for these inequality signs to be in the same direction. And in a contrary manner, if we have a function that is decreasing for all x, okay, as we go from x equals x sub 1 to x equals x sub 2, we're going to have x sub 2 be less. And so here we have up here f of x sub 1 and f of x sub 2. Okay? So we're looking for different directions on inequalities. Let f be continuous on the closed interval from a to b and differentiable on the open interval from a to b. And so we've seen this many times before. If f prime of x is greater than 0, so if the slope is greater than 0 on this open interval, then f is increasing for all x in the closed interval a to b. And on the other hand, if f prime of x is less than 0 on the interval from a to b, then f is decreasing for all x in the closed interval from a to b. And we have a few problems articulating this notion. And I'm going to introduce a few technical devices on how to analyze the distinction between the function f and f prime. And here we have the derivative g prime of a function. G is continuous and has 2 zeros. And where do we see these 2 zeros? Well, we don't see them at all. We see the prime. No, we see g of x equals 2 zeros. So here they are, the 2 zeros, this one and this one on g prime, because we can see them. If the domain of g is the set of all real numbers, which lends to continuity, right? Then g is decreasing on which intervals? So, what I want to do is demonstrate something called a number line analysis. In number line analysis, what we do is we look for our zeros, and we can see that we have a 0 here at x equals -2. So I'm going to put -2 over here. And farther along this number line, I'm going to put 2. And I'm going to put up above here g prime of x, and down below g of x. And what we're going to do is notice the sign of g prime of x to the left of 0, right? That's our first 0 at -2, at x equals -2. So the g prime of x value is positive from -4 to -2. And the value of g prime is negative between x equals -2 and x equals 2. So I put a negative over here, and to the right of 2, I see that f prime is positive, so I put positive up here. Now, another analysis tool that I'm going to introduce at this point is the relationship between f of x and f prime of x. And eventually we're going to bring in f double prime of x. But here I put a plus minus. I'm going to put 3 items here, or 6 items. Plus, minus. We're going to put increasing, decreasing, and then the last items we're going to put are going to be concave up and concave down. We haven't got to concavity quite yet. And then on this f prime of x row, I'm going to put plus minus, and then increasing, decreasing. And what we're looking at in this analysis is the relationship between these items here. Wherever f prime of x is positive, the graph of f of x is increasing. So if I go here in my number line, I see that up till x equals -2, the function is increasing, or the graph is going up. And between -2 and 2, we have a negative sign. So the underlying function, g of x, is going down. And finally, to the right of 2, we have positive, so we're going up. And it says, then g is decreasing on which intervals? Well, g of x is decreasing on the interval from x equals -2 to 2. And why is that? Because g prime of x is less than 0. So that's the justification. In fact, when we say on which intervals, we could pre-write the justification here because g prime of x is less than 0, and then write in the answer afterwards. So this introduces our number line analysis and also this relationship between f of x and f prime of x, that tool. And then later on, we're going to bring in another row for f double prime of x, but that's coming in future note card lesson. For 2 and 3, identify the intervals on which g is increasing and or decreasing. Justify your answer. Okay, so, and we have 2. It says graph g of x equals x to the 4th power minus 8x squared plus 1, and g prime simultaneously on the calculator. But even before that, I'm going to take that first derivative, and we're going to do I'm going to show a calculator here in a bit, but first thing we're going to do is find g prime of x here, and using our power rule, we get 4x cubed minus 2 times 8, or 16. So that's g prime of x. And then what we can do is, if we set g prime of x equal to 0, 0 equals, and we can factor out what? 4x. So 4x, and what do we have left? X squared minus 4. So for here, we're going to get 4x, and then using a difference of squares, we're going to have x plus 2, x minus 2. So using the zero factor property, we're going to have 4x is equal to 0, meaning that x is equal to 0. We're going to have x plus 2 is equal to 0, meaning that x is equal to -2 also. And finally, x minus 2 is equal to 0, our final factor, which means x is equal to 2. And so for that, if we perform a number line analysis, we put our zeros here, and we put g prime up above and g down below, and our critical numbers are -2, 0, and 2. Yes, critical numbers, and we talked about what these were earlier, didn't we? And so here are critical numbers, and so we can just analyze based on, if we take a number less than -2, we're going to have a negative times a negative times a negative, which means that function is going to be going down in this interval. Right, using our, remember we had f of x, f prime of x. We had plus, minus, increasing, decreasing, and concave up, concave down. And down here we had plus, minus, and increasing, decreasing. And so we're interested in this realm right here, the relationship between these. And then if we have a number that's greater than, between -2 and 0, say -1, we would have this be negative, this would be positive, right? Because we have, and this would be negative. So a negative times positive times a negative would be positive. So we're going up here. If we pick 1, we would have positive, negative, positive. So we'd be negative over this interval. And then if we're to the right of 2, everything is positive. So that's what the underlying increasing, decreasing would look like. And so we would say, g of x is increasing on -2 to 0 union 2 to infinity. And why is that? Because g prime of x is greater than 0. Okay, and then g of x is decreasing on -infinity to -2 union 0 to 2. Why? Because g prime of x is less than 0. So that would be our justification. And then graphing in a calculator, let's get that out, see what it looks like. If we have, here I previously graphed these, I'm going to change the window view. I'm going to go to Menu, Window Zoom, Window Settings. I'm going to go from -5, X-Min, 5. This is a TI Inspire CX calculator. Y minimum -15, Y maximum 15. I hope this gets them all here. Yeah, so this will be good enough. So this one in red is our original function. And what this shows, and this f prime of x, is this one right here in blue. Okay? So anytime we have the blue below the x-axis, we see that the red one is decreasing. When we go above the x-axis, what do we see? The red one increasing. And now the blue one is below the x-axis. We're decreasing all the way to where the blue is below the x-axis. And what happens when the blue one starts to go above the x-axis, the red one is increasing. So this verifies the analysis we already did here. Okay, then 3. It says justify increasing, decreasing. So I'm going to write below here. I'm not going to have a lot of room, but our critical numbers, we see where f prime of x is 0. So I'm going to put -3 here, and then also 2. I'm going to put g prime up above and g below. And to the left of -3, g prime is below the x-axis or negative, so the function would be going down over that interval. And then between -3 and 2, g prime is greater than 0, so the function, the graph, the original function, g of x is going up. And between 2 and infinity, we're also increasing. So we say g of x is decreasing on the interval -infinity, we don't see how far it goes, to -3, because g prime of x is less than 0. And then g of x is increasing on -3 to 2, and also from 2 to infinity. Why? Because g prime of x is greater than 0. Now, one thing you can do, because we don't have any, the thing touches, g prime touches at 2, so sometimes you'll see you can combine these two intervals into a single interval of increasing from -3, greater than -3, to less than infinity. So you'll see things written both of those ways, depending on who's doing the analysis and what we're thinking at the time. And you can make an argument for each of those. I'm not sure which I prefer. I guess as a purist, I might prefer the one on the bottom. Anyway, that's it. These are some helpful analysis tools. You're going to be able to use them a lot in the future. Good luck, and thanks for viewing.